So, like I said, it's 6.3 double angle, power reducing and half angle formulas. So we'll use those, we'll introduce those, then talk about how to use them. All right, so our double angle formulas, sine of 2 theta is going to be 2 sine theta cosine theta. I left off my S here. Cosine 2 theta is cosine squared theta minus sine squared theta. Then tan of 2 theta is 2 tan theta over 1 minus tan squared theta. All right. All right, so if sine of theta, if sine theta is equal to 5 over 13, and theta lies in quadrant 2, find the exact value of each. All right. So we want to find sine 2 theta. I guess I can write all three up here. Cosine 2 theta, and C is tan 2 theta. And so first, we want to find the missing piece. So we have sine theta is equal to 5 over 13. Y is equal to 5. R is equal to 13. And we need X. All right. Theta is in quadrant 2. All right, we'll come back to that in a second. So let's go ahead and find X. That's X squared plus Y squared equal to R squared. X squared plus 5 squared is equal to 13 squared. It's 25, 169. Minus the 25. X squared is equal to 144. Square root of both. Square and square root cancel. X is equal to plus or minus 12. And because theta is in quadrant 2, when we go to the left, X is going to be negative here. That should be a negative 12. All right. Problems before we go any further, make sure we're okay.
Good here.
All right. Thank you. Thank you. So we want to find sine. Let it go purple. So we need sine 2 theta. This is A. Sine 2 theta is 2 sine. Cosine. That's 2 times. Well, we know sine theta. That was already given. 5 over 13. But also cosine theta. X over R. Negative 12 over 13. So multiply across. 2 times 5 is 10 times negative 12 is negative 120. 13 times 13 is 169. And that should be the answer. All right, see chat. I've been late. No problem with the internet issues. I completely understand. Yeah, I'm recording, so we're good. You only simplify if it's possible. In this case, it's not possible. Down bottom, we have 2 prime numbers of 13. So since they don't have anything that can break down, then there's nothing for us to do. But if you could reduce, then you would be expected to do so. All right. B was cosine 2 theta. If I'm not mistaken, cosine, yep. We'll talk about other forms of cosine next. But that's cosine squared theta minus sine squared theta. So that's negative 12 over 13 squared minus 5 over 13 squared. 144 over 169. 25 over 169. That's 119 over 169. All right, last one out of this section. We have tan of 2 theta. That is 2 tan theta over 1 minus tan squared theta. Yep. Don't forget tan theta is y over x. So y was 5, x was negative 12. All right, so let's put it in the problem. So that's 2 times negative 5 over 12. 1 minus negative 5 over 12 squared. All right, so we can reduce this 2 times negative 5 over 12. The 2's can cancel into the 12, leaving you with 6. So on top, that's negative 5 over 6. In fact, do I want to put that up here? Come down bottom. Then 1 minus negative 5, 12 squared would be 25 over 144. So that 1 is 1 over 1 minus that 25 over 44. Common denominator is going to be that 144, so we're going to multiply top and bottom by 144. Just going over those fraction rules just to make sure we haven't lost them. Remember, adding, subtracting fractions need a common denominator. Now subtract. That's 119 over 144. All right, this is negative 5 over 6 divided by 119 over 144. So that'd be negative 5 over 6 times 144 over 119. Don't forget, whenever you divide by a fraction, you have to multiply by the reciprocal. Let's see, 6 should be able to go into 144, 24 times. Let me make sure I'm good. Yeah. So 6 can cancel out into 144 and leave you with 24. Multiply across, negative 5 times 24 is negative 120, and that's over 119. All right, questions.
None.
All right. Anybody saw another way of finding tan of 2 theta? Something we could have done? Anybody? All right, nobody saw it, okay. So tan of 2 theta, don't forget, it's the same thing as sine 2 theta over cosine 2 theta using our quotient rule. So I just went through the process to make sure we were okay with processes, these processes, because you may have to use it. But if you've already found cosine and sine of 2 theta, you can put the negative 120 or 169 over the 119 or 169. So negative 120 over 169 divided by 119 over 169. Multiplied by the reciprocal. Those 169s cancel. Now multiply across, we get the negative 120 over 119, which is the same thing we got right here. So that only helps though if you've already calculated, sine 2 theta and cosine 2 theta. Yeah, it was way easier. But like I said, if they just ask you straight up for tan 2 theta, that's when you need to know the process that we went through first. But if you've already calculated sine 2 theta and cosine 2 theta, then you can do that, use that relationship. All right. Questions? Any questions? Any questions? Mm-mm-mm. 210, 10 degrees. All right, so find the exact value of 2 tangent of 15 degrees over 1 minus tangent squared 15 degrees. So what we can do is use the double angle relationship. I still ran out of room. All right. So we were using the reverse of what we just did. Tan of 2 theta is equal to 2 tan theta over 1 minus tan squared theta. So what that means is I can take what we have here and let that be equal to tan 2 times 15 degrees, which would be tan of 30 degrees. So make sure we see the relationship and how we can double back or use it in reverse. All right. So if that's the case, you can use your unit circle. Fine. All right, you mean the right tan. Let me write it without that. Tan of 30 degrees. Sine of 30 degrees is square root of 3 over 2. Cosine of 30 degrees is 1 over 2. So you can place the sine of cosine, then reduce, you'll get that. Oh, wait, let me see, is it the reverse? 1 over 2 is sine. And then cosine is square root of 3 over 2. Yep, it's reverse. So sine over cosine. So sine is 1 over 2. Cosine is square root of 3 over 2. Yeah, for 30 degrees. So, yep. But either way, you will get square root of 3 over 3. All right. Questions before we look at some more. Okay, so we have cosine of 2 theta is equal to cosine squared minus sine squared. We already saw that one. But we also have 2 cosine squared theta minus 1 and 1 minus 2 sine squared theta. So we have 3 forms of cosine of 2 theta. So we want us to verify this identity. We have cosine of 3 theta equal to 4 cosine cubed theta minus 3 cosine of theta. So what we can do is look at that cosine 3 theta and actually break that up. Yeah, because of what we have at our disposal, that might be easier. So look at cosine 3 theta. We can break that up into 2 theta plus theta. We can use cosine alpha plus beta, which is cosine alpha cosine beta minus sine alpha sine beta. All right, so we're looking to break it up further. Remember, our goal is to have all cosines involved. So right now, let's look at our double angles. We have a double angle here and a double angle here. That cosine 2 theta, we can change that into the one that just have cosine involved, which is 2, I'll put a sign, cosine squared theta minus 1. Then here, sine of 2 theta is 2 sine theta cosine theta. So even though that still has a sine involved, we need to get rid of that 2 theta, because in our expression up here, all we have is just theta that cosine is being applied to. So we need to get rid of 2 theta. So we just keep moving with what we're doing. Go ahead and substitute those in. So that's 2 cosine squared theta minus 1 times cosine theta. And then here we have 2 sine theta cosine theta. And that's times sine theta. All right. So this one has a minus sign, so I'm going to distribute the cosine. So that's 2 cosine cubed theta minus cosine theta. Now this term over here does not have a minus sign, so I don't have to distribute. It's just multiplication. But I can multiply the sine times the sine in order to simplify. So that's sine squared times cosine, 2 sine squared times cosine. Now, for this sine squared, I can use the Pythagorean identity. Let me go over here. So we know sine squared plus cosine squared is equal to 1. If I were to subtract cosine squared from both sides, that means sine squared is equal to cosine squared minus 1. So this is the relationship that we'll use. Remember, our goal is to get all cosines. Oh, I rearranged my terms. I meant 1 minus cosine. Sorry, I subtracted cosine from both sides. 1 minus cosine squared. So basically, if I did this, all right. So let's substitute that in. right. So now we can distribute. We have this -2 that needs to go into each term and its cosine that can go into each term. So it'll be a -2 cosine theta plus 2 cosine cube theta. And now we can combine the like terms to see if we have our solution. So we have 2 cosine cube plus 2 cosine cube. So it's 4 cosine cube theta. And then here, 1 cosine, -1 cosine minus 2 cosine is a -3 cosine theta. And making sure yep, that's what we needed. So it just took a while, but we've proved it. All right, so power reducing formulas. We have sine squared theta equal to 1 minus cosine 2 theta over 2. So be careful, I left off that 2 initially, so make sure you go back and put that in if you didn't catch it. So it's cosine 2 theta over 2. Cosine squared theta is equal to 1 plus cosine 2 theta over 2. Tan squared theta is equal to 1 minus cosine 2 theta over 1 plus cosine 2 theta. All right. I don't know how much further you want me to go up. Is that what you need to see? Someone asked me to go up for a second. Just the new formulas. Okay. Yeah, I was gonna go back up to that. Yep. Okay. Cool. Yep. No problem. All right. So we're gonna use our power reducing formulas in the next example. All right, so write the equivalent expression for cosine to the fourth power of x that does not contain powers of trig functions greater than 1. So we're going to break down this cosine to the fourth power of x, or cosine x to the fourth power. Cosine x to the fourth power. Yeah, either one of them sound like you including it, but okay. So first thing we do is recognize that this is the same thing. All right. So of course that's not x being squared, but it's the whole cosine of x being squared. So, just to write it notation wise, this is what we're looking at. As a better notation, I should say. And we just saw that cosine squared is equal to 1 plus cosine 2 theta over 2. All right. So we can go ahead and square top and bottom. All right, so for all this out, so that's 1 times 1 times cosine 2 theta, cosine 2 theta times 1, and then cosine 2 theta times cosine 2 theta is cosine 2 theta squared. That's still all over 4. Combine your like terms in the middle. Cosine 2 theta plus cosine 2 theta is 2 cosine 2 theta. See if I can write this and make it look like. It's 4 going to all 3 pieces. Two over 4, just 1 over 2. And I'm writing that 1 over 4 on the outside. I went and turned them into thetas. Didn't we start off with x? Yep. Anyway, the variables, I went from x to thetas. We're supposed to be using x's, but it's just a variable, so we'll be all right. But yeah, we started off with x's. All right, so now we need to, hold on, there's a chat. I was wondering about that. Well, yeah, you should have said something. I would have turned it back to an X a long time ago. Got so caught up using these thetas. So we need to get rid of this square. And for the sake of the problem, I'll go back to X's. Maybe I even change it back in the notes after class is over. So that 2 theta should, that 2x should be fine. And make sure that not containing powers of trig greater than 1. So we're talking about the powers. So the 2x or 2 theta, if you want to stay right in theta, that is fine. But I do need to get rid of that power of 2 on this cosine over here. And so don't forget what cosine is being applied to is 2 theta, not just theta. So when I rewrite it using the power reducing, I would do 1 plus cosine 2 times 2 theta all over 2. I keep saying theta. I'm trying to go back to x, 2x. Like I said, I'm going to change them all back to x's just for note purposes when I get done. But they all should be x's, not thetas. All right, I can go ahead and multiply that. 1/4 back in there. And then 2 times 2x is going to be cosine of 4x. And 4 times 2 down bottom is going to be 8. This 8 can go into each piece just like the 4 did earlier. So that would be 1/8 plus 1/8 cosine 4x. To finish it all, combine our like terms, we have 1/4 and 1/8 as fractions that need to be added. All right, so that would be 3/8 plus 1/2 cosine of 2x plus 1/8 cosine of 4x. So we'll make sure I'm good. 1/2 2x 1/8 cosine of 4x. All right, that's it. All right, questions before we look at one more, look at the half angle formula.
Could you go back up to the top, please, of this problem?
All right. Right there.
Yeah, and then go down just a little bit more. I just want to double check my notes.
Mm-hmm. Just let me know when to stop or move.
Yeah, hang on right there.
Mm-hmm. While you doing that, I'm converting my thetas back to x's like they're supposed to be. I believe I was stuck on theta that bad.
You can just keep going and change them all. That'll be okay with me.
Yeah, all right. Okay, that's where I stopped. right, so before we go anywhere else, questions before we look at this last concept, half angles. All right, are we done with this problem? Very good.
Yes, I'm good. Thank you.
All right, you have angle formulas. Sine alpha over 2 is equal to plus or minus square root of 1 minus cosine alpha over 2. Cosine alpha over 2 is equal to plus or minus square root of 1 plus cosine over 2, cosine alpha over 2. Then tan, half angle of tan alpha over 2 has three different formulas, excuse me. Plus or minus square root of 1 minus cosine alpha over 1 plus cosine alpha. 1 minus cosine alpha over sine alpha, and then sine alpha over 1 plus cosine alpha. So notice those last two do not have plus or minus involved. And the note for this. All right, so the note that goes along with these formulas, the plus or minus does not mean that there are two possible values for each function. It means you must determine the sign based on the quadrant that alpha over 2 lies. All right, so let's use this. So they ask us to find the exact value of cosine 112.5 degrees. All right, let me go red. 112.5. No, I'll write it like this. Should erase all of it. Is equal to 225 over 2. So we can let that 225 be alpha in our formula. Oh yeah, quadrant. All right, so 112.5 is in quadrant 2. That means cosine is negative. So when we go to our formula, or also cosine of 225. I believe I need, cosine of 225. Square root of 2 over 2. So we're going to use the negative, which is where this came from. I want to use the red. And do 1 minus cosine. So it's going to be negative. That negative because, like I said before, we're in quadrant 2. Pi over that pi, alpha over 2 is in second quadrant. Cosine is negative in the second quadrant. Then cosine of 225 is square root of 2 over 2. Let me see. Let me go here. 225 is in should be negative 222. Not negative 222. Excuse me. Negative square root of 2 over 2. That's in quadrant 3. 225 is in quadrant 3. Yep. And so, yep, so cosine's negative. So it should be a negative right here. So I'll get 1 plus square root of 2 over 2 over 2. Negative sitting there. All right, I think I got everything good so far. Make sure negative out front. Negative square root of 2 over 2 is cosine 225. Cosine, let me go back, make sure my angle up here. Are you serious? All right, so this should have been a positive. I didn't look at my angle. I was trying to commit to memory, so that should be a positive, so this should be a negative. So, all right. But yeah, so that should have been a positive right there. And so that's why I went back and checked just to make sure. So now we can simplify, or we need to simplify this expression under the radical. What we can do is to simplify a complex fraction, we can multiply both sides, not both sides, but both top and bottom by the common denominator so that we can reduce it. So I can multiply this by 2 and this by 2. And that 2 needs to be multiplied to each term. And that 2 will cancel out with this. And that's what we're doing it for, so we can reduce. So it'll be 2 minus square root of 2. And then on bottom, that'll be 4. Then if I wanted to keep going as far as reducing, I can take the square root of the numerator and denominator individually. Taking the square root of that denominator leaves me with just 2. And that should be as far as we can go. Yep. And so pay attention to your symbols. As in your formulas, it's easy to leave a symbol or sign off. Yep. So most definitely take your time. Take your time. All right. Questions on anything I've written? Anything you need to re-explain?
Not right now.
All right. So we can do one more. We can verify the identity, and then we can close out. All right. Why would it be preferable to use that long convoluted expression versus the one Greater than 1. If you're talking about why you would use one expression versus the other, or one power versus the other, that depends on, it probably would depend on derivatives. That's one of the things, because it may be easier to do a derivative in a certain form versus another form. So basically, those answers you may find when you're in calculus. When you hit calculus, you may find out those reasons as to why. But there will be scenarios that you will come across where one form will be better for you than another form. And having a power of 4 versus not having a power of 4 would help out, or vice versa. These problems are so many steps on the test. Would you offer partial credit? For the part that you would actually turn in by hand, yes, I would be looking at making sure that you, if you had the correct process and you messed up on a step here or there, then I can give you partial. In my math lab, I guess it depends on how they have it set up. But everything's, I try to do whatever I can to give you guys points wherever I can give them. So, yeah. And we're really mad at the employees see. Well, hopefully not. So let's look at this last one, and then I will be done torturing you guys for today. So we got tan theta is equal to 1 minus cosine 2 tan over sine 2 theta. Yeah. 1 minus cosine 2 theta over sine 2 theta. All right. All right, sorry about that. Okay, so let's see where we're gonna go here. So we want to make this right side look like left side. Hold on 1 second again, I'm sorry. All right, so let's look at turn this right side into the left side. We have double angles involved. So let's look at turning that. Let's see, do I want to go cosine 2 theta into sine squared? I'm trying to do tan. Yeah, let's do that. So let's take, and cosine 2 theta has more than one form. So let's look at cosine 2 theta equal to 1 minus sine squared theta. So if nothing else, we know we'd have to get rid of these double angles because we don't have one in this form when we look at tan theta. And then the same thing when we look at sine of 2 theta. Sine of 2 theta is equal to 2 sine theta cosine theta. I should be right on that and make sure 2 sine cosine. Yep. So we have, when we go ahead and do our substitution, 1 minus sine squared theta. And then down bottom, 2 sine theta cosine theta. And there should be a 2 in front of that. Sine squared, let me check lab stuff. Yeah, there should be a 2 right here. And so it means there's a 2 right here. All right, so distribute that negative. And that's 1 minus 1 plus 2 sine squared theta over 2 sine theta cosine theta. 1 minus 1 will cancel. So that's 2 sine squared theta over 2 sine theta cosine theta. 2's cancel. And then, just in case you have to see it, sine squared is sine times sine. So one of those sines will cancel as well. That leaves us with sine over cosine, which is tangent. So it'll be very, very important that you guys make sure that as you use these, you are double checking yourself. You see how it's easy to leave off a sign or use a minus sign versus a plus sign. And of course, if you use the wrong one, then you won't get the desired result. So yeah, make sure you watch this as you go through it. Be careful, because you will get a different result if you use just a minor thing that is different than what they actually gave you. All right. So questions, concerns, comments before we close out today?
I have nothing.
All right. Thank you for that. Appreciate the response. So with that being said, Thursday, stay close to your emails. I will be emailing you either today, this evening, or sometime tomorrow to let you know if we'll be meeting at this time on Thursday. So, with that being said, I will see you guys on next class. Have a good one and be safe.
So the test thing,